Chandrayan-3, as the name indicates, is the third lunar exploration of India by Indian Space Research Organization ISRO. It was launched on 14th July 2023 at 2:35 p.m. according to Indian Standard Time at Satish Dhawan Space Center. The Chandrayaan-3 mainly comprises of three main parts, that is, the propulsion module, lander and rover. The entire spacecraft is loaded onto a launching vehicle named LVM-3. The full form of this vehicle is Launch Vehicle Mark III, which is used to carry artificial satellites and spacecrafts into the geostationary orbit. The purpose of this launching vehicle is that it will take the Chandrayaan-3 into the Earth's orbit and drop it at a certain point. After that, it is no longer needed. When finally the spacecraft reaches the Earth's orbit, it will start circling in an elliptical path. If we look at the elliptical orbit of the Earth, we know that according to Kepler's law of planetary motion that the Moon is closest to the Earth at a point, and then there is a point where the Moon is the farthest from the Earth. When the spacecraft reaches the farther point, the scientist sitting in the Space Center starts the propulsion module, which allows the spacecraft to drift away from the first orbit of the Earth and enter the second orbital ring, where the gravitational pull is comparatively less. Similarly, when the spacecraft reaches the second orbital, the propulsion module is again started. When the propulsion module is started, it again drifts towards the third orbital of the Earth. Similarly, after completing 5 to 6 such loops, the spacecraft gains enough velocity to sling itself towards the Moon's surface. Once it reaches the Moon, the reverse starts happening. Loop by loop, the spacecraft gets closer to the surface of the Moon. When the spacecraft is 100 kilometers apart from the surface of the Moon, the lander detaches itself from the surface of propulsion module. As we can see in the animation that how the spacecraft is drifting itself away from the surface of the Earth, moving in an elliptical path towards the Moon. The propulsion module will still keep circling around the surface of the Moon even if the lander detaches itself from it. It will act as a relay satellite and will be a way of communication between the lander and the Earth. The lander has 4 thrusters or engines which provide an upward thrust and slow down its descent. After the lander has landed softly, it makes sure that everything is okay and the trap door under the lander opens and guide rails slid through the door, where the rover comes out towards the surface of the Moon. The rover has wheels which enable it to move here and there and collect information about the lunar surface, do experiments, collect soil. It will also drill a hole to check the thermal conductivity of the lunar surface. The question that arises is that how we will receive the information. The lander and the rover will digitalize the data and transmit it in the form of electromagnetic waves to a receiver on the propulsion module which is still orbiting the surface of the Moon. The lander and the rover will be alive for just 14 Earth days because 14 days on the Earth is equal to 1 Moon day. Since the solar panels that provide electricity to the lander and rover need sunlight, they will be alive for 1 Moon day only. The objective of ISRO behind this mission was to get a safer landing as compared to Chandrayaan-2, observing and demonstrating the rover's loitering capabilities on the Moon and conducting experiments on the materials available from the lunar surface to better understand the composition of the Moon. If we compare Chandrayaan-2 and Chandrayaan-3, we came to a conclusion that the landing area has been expanded to 4.2 into 2.4 kilometers. And as compared to Chandrayaan-2, there is much more fuel in Chandrayaan-3, whereas in Chandrayaan-2, the fuel was not sufficient. The Chandrayaan-2 had 2 solar panels on the lander, whereas the Chandrayaan-3 contains 4 solar panels. The Chandrayaan-2 has 5 engines on lander to provide thrust, which was much more than needed and was a cause of its failures. That's why Chandrayaan-3 has been provided 4 engines to provide upward thrust. The only cause of failure of Chandrayaan-2 was that the ability to handle parameter dispersion was limited in it. But in the case of Chandrayaan-3, many improvements have been made so that the failures of Chandrayaan-2 can be overcome. Thank you.